Hi there, this is Chris again, going over some Scratch programming. Last time we made this little basketball game where our cat was running around catching basketballs, and I got some questions about how can we make it so the cat can move up and down too. Maybe jump. Jumping is a big part of basketball, right? So it's super easy. I want to go over a quick way to show how you do that. Here, we're using the right arrow and we move right, and we have the left arrow to move left. So what would you think we do? Let's just try making an action with the up arrow. But every time we do that, we point in a new direction and what direction we want to go when we go up. They have left and right, or right and left, and we have up as well. So let's try that. Let me try that in a bigger area. Oh, it's a little slow. And we can move up the screen. I can't move down, but I can move up. So how would we add down? Same way. Let's just duplicate this and use the down arrow. And instead of pointing in the direction up, we'll point in the direction down. And we'll move again. Let's try that again. And now you see, since I can move up and down when I start the game, sometimes I start in a strange place. So maybe we want to restart the game. Or restart, when we restart the game, we want to move the cat back down to a better location. How would we do that? Well, when the green flag is clicked, we want to move the cat. Let's see, where do we move the cat? Right there. And if you go to the motion blocks, you'll see that they have a go to 0 minus 132 location. That's where he is right now. So you can just use that as a shortcut to always put him back there. So when the game starts, even though my cat is hiding there, when it starts, he's going to go back down there. It's perfect. Okay, so now our cat can run up and down. But it's kind of a lot of keys to be pressing. So you might think, what would be an easier way for the cat to move around? And some people think, well, let's try using the mouse. And the mouse is a very good answer for that question of how could it be easier. So we look at our motion blocks, see if there's any that can help us here. And I like this one right here. Go to mouse pointer. And so when would we want to go to the mouse pointer? Whenever the game is playing, right? So it'd be sort of in the same forever loop that whenever we check to see if we're touching the basketball, and then after that, we go to the mouse pointer. And if we run this, what do you think is going to happen? Look at that. He just sticks to the mouse pointer. Excuse me. Sorry about that. Allergies. So he sticks to the mouse pointer, and that works really well because we can move around real quickly. Except that he spends 2 seconds saying, I got it. So why is that? He's spending a couple seconds saying, I got it. Well, that's because here we say got it for 2 seconds, and we're not doing anything else during that time. We aren't going to keep updating our mouse pointer till after that say 2 seconds runs. So what we have to do, and this is kind of a complicated computer science term, but you do it all the time on your own as a smart little human being, do 2 things at the same time. Rub your belly, pat your head, right? You can do that. So we're going to make our Scratch cat do the same thing. We're going to have 2 blocks of code that are updating all the time, and they're going to happen when the green flag is clicked. So now, in one loop, he's always moving and following the mouse, and in the other loop, he's checking to see if he's touching the basketball. And so that way, when he says got it for 2 seconds, it slows that one down. But it doesn't stop us from moving. Now, as we watch this game, it gets just a little bit too easy, don't you think? Where he's instantly moving as fast as your mouse moves, which can be a little bit too fast, I think. Right? The ball is falling at a certain speed, and he has no speed limits. So to make it a little more challenging, let's slow our cat down just a little bit. And so instead of going directly to the mouse pointer, let's have him point towards the mouse pointer and move that direction. So if we move 10 steps, when he starts now, he's a little bit behind the mouse. If you move the mouse real fast, the cat can only move 10. Let me blow this up a little bit. He can only move 10. But you see this strange thing when he catches the mouse pointer, and that he goes back and forth a lot. And why do we think that is? He's sort of not sure. Do I want to go right? Do I want to go left? Do I want to go right? Do I want to go left? And that's because he's moving 10 steps at a time. Imagine you have a piece of a big grid here, and there's lines every 10 pixels. That's how many spots he's moving, every 10 steps. Well, I'm not putting my mouse. When I move my mouse, I'm not moving it 10 steps at a time. I'm moving it maybe 1 or 2 sometimes. So you imagine he's moving on this grid of 10 steps at a time, and that's too many. We can't be on that grid. He's going to flip back and forth, always turn left, always turn right. So what we have to do is a little bit of funny. We have to check to see, hey, is he close enough? And if he's close enough, then we don't have to move. And doing close enough is kind of some complicated math. But basically, we need to check the mouse's X position and the cat's X position. And if their X values are within 10, then we won't move. And so we're going to use a tricky little mathematical function called absolute value. And it's hidden down here in the mathematical functions group. So we could do absolute value, floor, ceiling, square root, all these math functions. And we'll go over them over time, but we're going to start with the first one, ABS, absolute value. And that means the positive value of a number. So the absolute value of 3 is 3, and the absolute value of -3 is 3. And this helps us in the case where we're going to check to see if the difference between the mouse location and the cat location, and we're going to subtract the two. We're going to say mouse X minus cat X. And sometimes that's going to be positive. In this case, let's say that this mouse value is 40 and the cat value is 30. So it's going to be 10. But in this case over here, where the mouse value is 20 and the cat value is 10, we also, 30, then we would get -10. And we really don't care if the mouse is on the left side or the right side of the cat. We just want to make sure that their difference is not more than 10. So that's what the absolute value function is good for. We can take the difference of two numbers and it'll give us the absolute value, whether how far away they are, regardless of which one's on the left and which one is on the right. So now we got to grab those values. I know that the position of our sprite is in the motion area. So we take the position of the cat there with that one, and in sensing they have mouse X. So we just subtract those two and take the absolute value, and that will give us how far apart in the X dimension those two objects are. So we finally just need to put something in an if, and we will say greater than. So if the absolute value, the difference in locations between the mouse and the cat is greater than 10, then we want to move towards the mouse. So now we have to get a little if statement, put that in there. Drag this. Oops, I don't want just the absolute value. I need the greater than. Grab the greater than. So now our logic is saying if the distance between the cat and the mouse in the x dimension is greater than 10, then we're going to point towards the mouse pointer. And let's see if that works. And so now when it's less than 10, when it's 8 or 5 or 4 or 0, we're not going to move. And so that calms the cat down when it catches the mouse. It doesn't want to go left and right and left and right and left and right again, like it was doing earlier. But now we're only checking the x. And so what could happen? What does that mean? Well, that means if we change the y a lot, our cat doesn't move, because the x hasn't changed that much. So we're really close, but we have just one more little thing to do. We need to do the same thing, but check for the y. So instead of x position, we want to use the y position of the cat, which is this blue one here. And we can recycle this x position. Same thing for the mouse. Recycle that mouse one. And then we want to put that in the if, and we'll combine it and or. Let's see. So it's strange because in English, and and or are kind of different than they mean logically. But here, what we're going to do logically is say, if the x position is greater than 10, the distance between the mouse, and the y is greater than 10, then we'll move. It's actually or, if either of those cases is true. So if there is too much space between them in the x or the y direction, then we will want to move. And I got to slide this in there somehow. I can't. Let's see what's going on with my or. Put that one in there. What's going on? Sometimes it's a little tricky. There, so you see when it lights up with the white outline, that is ready to take it. And so I couldn't put it in. It's kind of using the left side of this thing, and I was trying to use the mouse to put it in there. So get your left side lined up, and then it lines up there. And I'm going to take this. I need to line the left side up. And now that's a super long statement, but it's really simple when we think about it, that if the mouse and the cat, their distance between the two in the x or the y direction is greater than 10, then we're going to move. So let's try this out now and see if it works. So now if I go straight up, he's still following. I think now it's a little bit more of a challenging game because it doesn't move instantly, and you sort of have to anticipate where the basketball is going to be with your mouse. And then you lose after a certain moment. All right. So we covered some different things here today just to expand the game a little bit. We use the keyboard to move the mouse, and you'll see that still works. Oh, we forgot one little thing here. When the keys are moving, we change costumes. And we didn't do that when the mouse is moving it. How could we do that? Well, this next costume is what switches it. Do we want to switch it all the time when we're in this loop to see if we're checking the basketball, or all the time when we're moving? Probably when we're moving. So we go into the looks, find the costume command, and after we move, we want to switch costumes as well. That looks better now, right? The cat's running around. And so the keys can move as well, but then you'll see that he always wants to go back to where the mouse is. So even though we have all those key commands that will move the mouse or move the cat to where the sorry. We have all those commands to move the cat with the keyboard. They are all being overridden by this loop here that always wants to go back to the mouse pointer. So we could throw these away if you want, since they're not very useful. And now that we have a routine that is moving the cat by the mouse. So we covered adding some extra keys to move up and down, which was pretty simple. And then we went to moving the cat with the mouse, which in the end is simple, but in the beginning it took us a couple tries, right? First, when we did it in the one loop, we had to wait 2 seconds while we were saying got it, and that ruined the flow of the game. So we made a second loop so that our cat could be doing 2 things at the same time. Okay, so that was good, but then it started to flip back and forth, and we had to use some math to decide when do we actually want to move. And we only want to move when the mouse is far enough away. We did that, testing in 1 dimension first, in the X dimension, and then we fixed it so that it follows in the Y dimension as well. All right. I'll see you next time. Let me know if you have any questions for these. Hopefully this was pretty fun. Bye-bye.